Okay, I've started to record it. Now, what you should see is a table. Can everyone see the table?
Yeah. Yeah.
Okay, what today is about, and I don't know whether you guys have noticed that on your bins, you have these labels.
Yeah.
Okay, now Steve, do you have the part numbering system with you?
No.
All right, well, we'll just carry on. But for you guys' benefit, for your benefit, red always tells you what the shape is, A, B, C, D, E, F. And when you look at the part numbering system, you'll see that. Blue will always tell you the thread, and yellow always tells you the size.
Yep.
So what we're going to deal with today is the yellow, the size. How do you measure something and know that you got the correct size? You guys okay with that?
Yep.
Okay. Now in hydraulics, in hydraulic hose and fittings, but in hydraulics in general, everything's measured in 1/16 of an inch. So you can see the 1/16 of an inch?
Yeah.
So you 1/16, 2/16, 3/16, and so on. But what it always does, it goes to what's called the simplified fraction. So 2/16 becomes 1/8.
Yep.
4/16 becomes 1/4. 5/16 becomes 3/8. You go to its lowest fraction. Does that make sense to everybody?
Yeah.
You don't have to know much more than that. That just tells you the why. Now, it works in a dash size. So you can see 1/8 is 2 or 0.2, which means it's 0.2 or 2, and it tells you its dash size is in 1/16 of an inch. So no matter which catalog you look at, no matter where you go in hydraulics or fluid conveying, you will always see things measured in 1/16 of an inch, moving to its simplified fraction. So if I said to you 8/16, what's its simplified fraction?
1/2.
Yeah, so that's half an inch, right? What would its dash size be, Jake?
Dash size for that one?
Yeah.
Yeah, 8 or 8.
Yeah. So whenever you're looking at a catalog, that's what it'll say. In our language, it's 08. But if you're looking in a catalog, or if you're ever looking in a catalog, it'll either say 8 or 08 as its dash size. And then if you measure it with a caliper, you're going to get 0.5, or in millimeters, you're going to get it 12.7. So the thing that's most confusing about our industry is it's caught between the American system and the European system, right? So the Americans are imperial, and Australia and the Europeans are metric.
Right.
So what you've got to understand is it usually takes the American system, which is imperial. So it goes in 16ths. But if you see something that goes to millimeters, its dash size will be in millimeters, and usually the buggers round off. So if you look at any of the hoses we've sent, you'll see that they'll have both imperial and metric, just to confuse you some more. Does that make sense?
Yeah.
Any comments, any questions? Steve, does this make sense to you?
Yeah, well, I've done a lot of pipe work, and yeah, you've got to work with DN sizes in pipe work, and you know they don't necessarily line up, or they do line up, and I do understand how they line up. So you know, DN 20 is actually 3/4 of an inch, which is really 19 mil.
Yeah, so you can see down on, you've got this chart. I've given you this chart with all the information I gave you, Stephen, the part numbering system.
Yep.
If you refer to this chart, it will always give you your dash sizes. If you're measuring it with a vernia, it will give you all the verniers, like in imperial and metric.
Yep.
So if you're using a vernier, this is a very helpful tool. All right, and just to show you as you go down, that's simple. So when you get to something like 3-inch, its dash size is what?
You get 3 inches, 48.
48. So whenever and you won't see fittings, too many fittings with a dash size of 48, but you'll see lots of hoses that go beyond that. So you might even see suction hoses, and even the hoses that you have for your air seeder hoses, they could get up beyond that, and they might reach 76 millimeter. Is that making sense to you guys?
Yeah.
Okay, so I just want you to really get that it's actually quite simple once you get your mind around it. This chart gives you the information. Like if you're measuring it, it gives you the information you want, both imperially and metrically. Can you see that, Steve?
Yeah.
So that's quite, that's quite, you know, when I say it's quite easy to see, I developed the thing from all the information. Any comments, any questions?
None so far.
Okay, so when you go and you look at all these tags, when you see the tags there, we've already put the sizes on the tags for you. And that's how you'll be able to relate to them. Does that make sense?
Yeah.
Okay. Now, I'm going to go into the part where we left off, Steve. This is one of the hardest things to remember in fluid conveying. And what it is the difference between a pipe and a tube. Steve is very, very familiar. He's probably one of the few guys I've ever spoken to that really understands the difference. Now, when you're talking about a pipe, how do you measure a pipe?
Okay, these guys probably don't know that.
Okay, but
Pipe is measured by
way is to ask. So both Jake and Jacob, the easiest way is say, how do you measure a pipe? Always ask the question. Don't be frightened to ask. It's not about, I don't judge you by anything other than why would you know? Okay, so if you don't know how, that's fine. No problems at all. Steve will explain to you that when you're measuring a pipe, and let's see how good I am.
Mate,
When you're measuring a pipe,
it's the nominal bore of the pipe.
okay, can you see the little red circle that I've created?
Yeah.
Okay, now let me create another one. Let's just see how good I am. You're testing me now.
Okay. Tubes, pipes are measured nominal bore. Okay, and it's only an approximation. All right, and it's a very, very complex thing. A half-inch pipe is roughly a half-inch bore, but it changes depending on the wall thickness. So it depends on whether it's a standard weight pipe, and you can have standard weight, you can have heavy, you can have extra strong, double extra strong, you can have Schedule 10, Schedule 40, Schedule 80, Schedule 160, Schedule 120. There's just so many ways of measuring a pipe, and they're about 1 inch or whatever size inside. So if anybody's talking pipe, it's an approximate size of the inside of the pipe.
Yeah, and pipes are actually been bastardized over the years.
So pipe is a nominal ID. A tube is measured on the OD of the tube, the outside diameter.
Okay, so can you see that there? When you're measuring a tube, you're measuring on the outside diameter, and it's very accurate. When you're measuring a pipe, as Steve said, today it tends not to be so accurate, but it is the ID. It's very important because what we're going to be talking about today, we're going to take particular threads. The threads we're going to talk about are JIC, BSPT.
Okay, just hang on a second there, Gilly.
Sure.
We're on a video conference. How can we help you out?
No,
Oh, all right.
you're on video. You're on air. You're on.
Yeah. Yep.
Standard, Adam?
Yeah. Right.
No, we got a video conference.
Yeah, right. Yeah, interesting.
Have you got one of our invites?
Yeah, put an email. I said I'm coming.
Yeah, okay.
28th, 25th, or 6th, or 7th,
No.
whatever it is.
No. Not only the Speedway, but who's masters open.
Was it in the mail?
It was in with your invoice. If you got
Yeah,
the
I would
invoice,
have got it. Definitely would have got it.
23rd.
That sounds interesting. Right, so, mate. So, yeah.
And it was 15.40.
Yeah,
Yep.
that's the only one. The only you can all use. Nothing else in the market like.
You're probably right.
Good shit. I want to use it 15 years.
Yeah.
Love it.
Okay.
You go to Canada, I went to look after my brother-in-law who died in a year on. He had his bucket list to go back to Canada, so I looked after him for 2 weeks. And went all through Canada while I was there.
Yep.
And guess what?
That's what they use.
And in America, it's all they use. Conoco is the biggest company you've ever come across. See you, boys. See you on the Speedway night. Well, you better give me some details. Email us what time to meet.
Can you get in here and are you going to be in here sometime next week?
Yeah.
Okay. Well, when you come in next week, I'll give you the tickets.
And tell them I'll talk to them about Canada. I'm Canadian.
Sorry, Kelly.
Tell them I'm Canadian.
All right.
So you can't bullshit us about Canada.
Oh, well, he's telling me that this Conoco oil that I sell is the best thing that happened to the world since sliced bread.
Yeah, well, that's Texan oil.
Is it?
Yeah, Conoco is a Texan company, but it is oil field. It is a very common oil that's used in all the oil fields all over the world.
All right.
For their lubrication.
Yeah, well, John's got a lot of people here using it, so I just keep selling it.
And it's expensive.
Yeah.
Why would you not sell it if they're buying it?
Yep.
So that's fine. You're gonna get this. You're gonna get this in your video too. You realize that, Steve?
Sorry?
I never paused the video, so I just kept going.
Yeah. Okay. Anyway, you can keep going. Jake will be back in a minute.
Okay. As I've said, what we're going to talk about is a JIC thread, a BSPT thread, a UNO ring thread, and an ORSF thread. Those are the threads that you have on the premise today.
Do you want me to go and get one of each so Jacob
Yeah,
can have
that would be fine. I've got pictures of them here anyway.
All right. Sit down and listen.
Thank you. All right. Apologies about that.
Okay. So, Jake, what we're going to talk about is JIC. Have you ever heard of JIC?
I believe Steve has mentioned it. It's a joint international conference?
Yeah, that's what it is.
Yeah.
But it's a 37-degree flare fitting. But that's not as important. I'm gonna tell you whether it's a tube fitting, or a pipe fitting, or a stud fitting.
Or a stud fitting.
Yeah, and you'll see in a minute. So I'm gonna go through this first, and then I'm gonna show you how they seal.
Okay, gotcha.
Okay. So both of you can see my chart?
Yep.
Okay, you can see on the left-hand side you have ORSF thread size.
Yep.
And then you can see you've got tube size going down the next one, third one along, right?
Yeah.
Okay. Do either of you know what a TPI is?
No.
No.
Threads per inch.
Okay.
And so when you're measuring most fittings, it's about their pitch and their thread per inch. So when you're looking at this, you'll start to see, as it moves along, you'll start to see what the thread size, and what it is I'm going to teach you how to measure the thread. So the OD of the thread. But the OD of the thread is not going to help you with the tube, is it?
No.
No.
No, because it's a tube fitting. So if you measure the thread, you'll get confused by its dash size. See where I've got the dash sizes?
That's
Yeah.
right.
See, I've got dash size and dash size?
Sorry, yeah. JRC and ORS and UN.
You know ring. So what I want you to understand is JIC fittings and UNO rings are the same thread. They just seal differently.
Okay.
All right? But both of them have, when you're measuring them, both of them will have TPIs. So you can see the TPIs. So if I'm using ORSF, you can see the ORSF column.
Yep.
And I go 13, 16, how many TPIs does it have?
-16.
It's dash 16, so it's 16 threads per inch.
Yeah, 16 is ring, so it's just
Okay, what's its dash size going to be?
dash size. That one?
For the UN or?
Yeah, for the ORSF, if you just follow it along, what's its dash size?
8.
8. Oh, 8. Exactly right. So if I do 2 or 2 inch, how many TPIs?
For 2 inch, 12.
Okay, what's its dash size?
Dash size of 24.
Wow, that seems like a big difference, doesn't it? When it should be 32, why is it 24? Now think about it, it's a tube fitting. What's the OD of the tube?
That's what that is.
So when you think about it, let's see if I can draw it for you. When you think about it, you've got this nut. That's the nut, right?
Right.
Now what you have is the nut fits onto a tube. Now, is the tube's going to be smaller than the nut, right?
Yeah.
Why?
The nut has to go around the tube, not
Yes, but it's got to have a thread.
it's going to have the thread in.
See that?
Yeah.
Counter for the OD.
That's how it anchors to an adapter. So when you're looking at it, see where it says 2 inch. 2 inch would be measured across here. And that will equal 2. Does that make sense?
Yeah.
Yeah.
Okay, so what would if I measured across this, what would it equal? Inch and a half,
Inch and a half.
which is 24. That's how you get its dash size. Does that make sense?
Yeah.
Yeah.
Because what you really have, and this is where it confuses people, and this is our business. Because they'll measure it and they'll give you one measurement, but you'll have no clue. Are they measuring the thread? Are they measuring the tube? Are they measuring the pipe? What are they measuring?
Yeah.
So if you understand this, see where it says 2, So the 2 equals the thread, but it's 1.5 inches because it's a tube fitting. Sounds a bit confusing, doesn't it?
At first.
You understand? You're measuring the tube size. Why is that so important when you're working on machinery? What if you can't unscrew the nut? You can measure the tube with that and get an accurate thread size. You understand my point?
Yeah.
Right, yeah.
Okay. So now, what we're going to talk, that's ORSF. Now, you're talking about JIC. JIC is a tube fitting. You see that?
Yeah.
Both ORSF and JIC are tube fittings. But what you've got to see is when you're looking at the ORSF at 1/4 inch dash size, you can see what its measurement is. But if you look at it in JIC, it's different. It's 7/16. So they're different thread and they're different TPIs. Notice one's 20 TPI and one's 18 TPI.
Yeah.
And what you've got to be is just aware of that. And when you start to look at it, and we'll go into the seal later on in this session, but I really want you to understand, it seems confusing, it's not. And if you ever run into trouble, you can phone me and I'll talk you through it. I've talked more people off the wall than you can imagine. All right, so same deal. So if I'm looking at JIC, this is now JIC threads, right? And it moves this way. The table moves this way, and then it goes left to right, and then it goes right to left. Does that make sense?
Yeah.
So now when you're looking at the dash size, when I say on this one, a 3/8 JIC, what's its dash size?
3.
3. Now here's the part that's going to confuse the hell out of you. U and O ring, remember I said you have a stud fitting? That screws into a port. You know when you screw into a port on a machine and it's a parallel port? It's exactly the same thread as a JIC, but its dash size changes because it seals differently. So now when you look at it, it goes U and O ring, but its dash size. See there where it says U and O ring?
Yeah.
Its dash size is here. See that? So a 3/8 instead of being a dash 03 is a dash 06. That's why it confuses people. And once you understand, you have pipe fittings, tube fittings, and stud fittings. ORSF and JIC are tube fittings. U and O ring is a stud fitting, and it screws in and it anchors and it doesn't seal in the same way. That's what you have to remember. Does that make sense to you? Any comments, any questions? Once you've done it a few times, it is dead easy, but it seems complicated right now.
So that's a JIC.
So just to clarify then, Kelly.
Yeah.
So it's actually about the difference between JIC and ORS and the UNO rings, pretty much the way it fits.
Yes, that's exactly correct. It's the way it fits. It's not so much the way it fits, it's the way it anchors.
Okay.
Okay, it anchors, then it seals. So you have to, our whole business is about anchoring and sealing.
Right.
So when you're dealing with threads, the only question is it anchoring, is it sealing, is it tube, is it pipe, or is it a stud? That's what confuses people. When you watch this again, it'll be clearer in your mind. Now, when you see the ORSF, right, you've got the ORSF fitting in your hand. Yes?
No, hang on. These two are the ROS here. Okay.
Okay. Good.
I'm trying to get the right draw. Okay, you can see
You in Owen?
but it's flat, right?
The ROS here,
Yes.
flat, and the other one's flat, and it's got no ring in the middle of it.
For some reason, it's not giving me my drawing pen. Okay, so let's try it like this. Okay, here we go. You see, it's got the thread there, and it's flat. Right? It's flat here.
Yeah.
That's where it seals. You have the tube coming down through here, but it seals right there. It anchors here and it seals there.
Look at that. You can see how that sits hard against that, and the thread pulls it together, and then the O-ring will seal it.
So it'll lock itself.
Yep.
Now with the JIC,
That's JIC.
it looks like that, right?
And that's JIC.
A conical shape of sorts.
And so it anchors here.
Okay, can you see how that seals onto that, and the
And
threads?
it seals here. You understand? It seals on the cone.
Yeah.
So the opposite male will be the opposite cone, and on the flat face, the male will be flat with an O-ring.
Yeah. Yeah.
Okay, you understand that?
Yeah.
So once you've done it once or twice, it is dead easy, but you need to understand the anchor, the seal. Is it a tube? Is it a pipe? Or is it a stud? Okay? Steve, have I explained it well enough?
I think so. That's a pipe thread.
Okay, what I'm going to do now is when you're looking at it, BSP is a pipe thread and it's measured by its pipe. I've got to take these off so I can change my screen. If I leave those on, it won't record very well. How do you like that for technology, Jake?
Yeah. I like it. Hardware rather than software sort of thing, eh?
Yeah. Okay. Now, what I'm not going to do is most metrics are tube fittings, but we're not going to deal with metrics today. But you can see down here the point that Steve and I have been making to you. If you read it in your catalog, and the thing that I gave you, it actually talks to you. And let me do it again. Okay. Let me know if you can see my new screen.
Yeah.
Okay, I'll switch that across. Okay, so you can see my screen now?
Yeah.
Okay, fitting selection and fitting identification. If a thread cannot be identified by screwing a mating part into and onto the fitting, then the following procedure is followed. Tools required: a vernia and thread gauges, imperial and metric thread gauges. Because what did we say when you're measuring a thread? you measure the TPIs as well, right?
These guys probably don't know that, but so they're learning that at the moment.
Yeah, no, I've explained it to them before. I showed them the TPIs. And what I'll do when I come up, I'll bring you thread gauges when I come, and I'll show you how to do it. How's that?
Okay.
Okay, but the two tools you require are a vernia and thread gauges.
Yep.
Okay, so now you can see here where it says thread pitch, and you can see in imperial thread, metric thread, and you can see it's TPIs, number of teeth per inch, and in metrics, it's the distance between the teeth. Okay, don't get too caught up in it right now. Just know that I'll teach you that when I come, and I'll show you the gauges, and I'll physically allow you to do it. Any comments, any questions?
No.
And you can see it okay?
Yeah.
Okay, and believe me, the recording will be as good as you see it now. So you can go back and you can look at the recording. Okay, so fittings identification. By using the thread gauge, the pitch of the threads can be determined. See how you use the thread gauges? The gauge should fit tightly into the thread with very little light showing. So we'll show that to you, but just to give you an idea. So you can see the threads. Jacob, can you see the threads?
Yep.
Imagine a little steel thing going in, and it'll fit snugly.
Yep.
And I can tell you, I've dealt with people. I did a job last time I was there for Komatsu, and they had threads they couldn't identify. And here's guys been in the business 20 years. They went to every single operator. They went to Pertec, they went to NZ, they went to Commentaries, they went everywhere. No one can identify the threads because they didn't use their thread gauges. First thing we did was we pulled out our thread gauges, worked out what the number of threads or the pitch or whatever. We worked that out, and it took us 2 days to solve it. But in the end, we were the only company in Perth that solved their problem. And it's because we train people to understand the engineering standards, not the stuff that people talk about is the brand and everything else. This is an engineering standard. This is not created by us. It's not created by most of the brands. It's actually an engineering standard. And Steve will tell you, as a draftsman, that's exactly where you go, to the engineering standard. Am I correct, Steve?
Yep.
Always. Okay. So now we've got the different types of seals. Now remember what I said to you, that we seal and we anchor. So you can see a taper thread there. This is BSPT. How does that seal? How does a taper thread seal?
Metal to metal wedging, it says here.
Yeah, so it actually distorts. So in today's world, it's just about a no-no. Because what happens is if you're going into an alloyed valve with a steel fitting, what do you think it does to the valve?
It would damage it, wouldn't it?
It strips the thread out. It'll cut the thread right out of it, and then you have to retap the thread. So what you're more likely going to see on any machinery today are parallel or stud. So UNO ring, BSP parallel, and see where they seal? They don't seal on the thread. Can you see where they seal?
On the O-ring or the...
On the O-ring or a Dowdy seal, but they don't seal the way most people think they seal. The thread only serves as an anchor to hold it against the pressure of the oil or whatever's flowing through it. When you're looking at a taper thread, it's doing both sealing and anchoring. But in today's world, that's not the way it's going to go. It's got to go. Each job is a separate job. You anchor, you seal. Does that make sense to both of you?
Yeah.
Now, what it's saying here is you can actually put a taper fitting in a parallel hole and it will seal, but it'll screw the hole up because it distorts the threads.
Yeah.
So a lot of times people will say, oh, you can do that. Yeah, you can do that, but just be aware you're going to screw up whatever you're screwing into. Does that make sense?
Yeah.
How are you with that, Jacob? Do you understand that?
Yep.
How would you explain it to me?
I wouldn't know.
Yeah, you have to match. Yeah.
So everybody else is-
Once you've done it a few times, believe me, it's second nature.
That's good. Yeah, after a while.
Yeah. So don't be too worried about what you don't know. It takes about 18 months to understand this, but by the time, believe me, you will be experts in it because that's what we do. We're fluid conveying specialists. Now, remember the UNO ring?
Yeah. Yeah.
Okay, there's the male, there's the female. And you can see what they do. This screws up and see the O-ring?
Yeah.
The O-ring will seal.
Yeah, most of your farm equipment today, any of the new equipment in your areas are either going to be metric or UNO or ORSF. There will be lots of JIC, but it's going by the wayside because it's middle to middle. See the little rubber seal here? That's a soft seal. And when it goes up against the face, it's a much better sealing proposition. Your John Deere's, your Massey's, all the American tractors that you have, or all of that will be ORSF. That's why you have it. And what we'll have to work out is there's a good chance you've got a lot of metric in that area, but when I come up and do the session with the farmers, I'll find that out, and then I'll teach you what you need to know. How's that? All right? The thing that you have to remember is you don't have to remember any of this stuff. What you have to remember is the fundamentals. What are the fundamentals? Sailing, anchoring. Is it a tube? Is it a pipe? Is it a stud? That's the 5 things you have to remember. That's the fundamental. Does that make sense?
Yeah.
Yeah.
Okay, so what's the first thing? How's it sealing? How's it anchoring?
Yeah.
That's all you have to ask yourself. How does it seal? How does it anchor? Does that make sense?
Yeah.
Yeah.
And you can see there exactly what you're doing, Jacob. You can see it's going to anchor, and as it screws in, it's going to seal.
Yeah.
Okay, and there's more to it, but for the threads, that's all we need to know right now. How you going with that, Jake?
Yeah.
Make sense?
Really getting there.
Okay. Now, let's see what my last slide's going to say. Okay, let's see if that'll go. I don't know if that's going to stay up there. Okay. So you can see what I've done.
You also see with this is that you can have this pointing in any direction you like.
So you'd have to angle that before.
Yeah.
All right. Can you see on the screen I got BSP T and BSP P?
Yep.
Okay, that's a chart. Now, BSP is a pipe fitting. So if you want to be screwed in your mind, believe me, this is the one, because you'll measure and it'll never make sense to you. The dash sizes will never make sense. Right? But that's something that when I get there, I'll show you exactly what I mean. But I put this on there so you can actually see it. Now, can you see that I'm showing you the way it seals, the way it anchors, and the threads, and all the dimensions of the threads, right?
Yeah.
Okay, now what do you see with the JIC fittings? Can you see exactly the same thing? Can you see that?
Yeah.
Okay, now the fundamental difference is this is a 30 degree, but it goes into it. So you can see you've got 30 degrees there, and you've got 30 degrees here. So that little piece there screws into this face here. And that's how it seals. Oops. Okay, so that's how it seals. But look at JIC. It's going out on the male and in on the female. Can you see that?
Yeah.
It's the opposite on, but this one now is 37 degrees. That seal is 37. That's not really probably not something that you're going to have to worry about too much. But at this stage, I want you to know when you're looking at it, that's what you're expecting to see. Does that make sense to both of you guys?
Yeah. Oh, so
Jake, does it make sense to you?
Yeah, essentially just identifying the difference between the two standards. Is that what we're?
Exactly right.
Yeah.
And so when you get there, just I want to lubricate your mind, if you like, to be aware of what's going on.
Okay.
Okay. Now, you see there, you can see this is a JIC male.
Yeah.
See the cone's going out. This is a BSP male and the cone's going in. Can you see that?
Complete opposites. Okay.
But this one's 30 degrees. This one's 37 degrees.
Did you say so? Did you say the BSP is 33, Kelly?
No, 30.
30. And then the JIC is 37.
Yeah. Now, do you want me to tell you how they got the Joint Industries Conference?
Yeah.
Okay, so the JIC used to be SAE. SAE was Society of Automotive Engineers, and it was 45 degrees.
Right.
So the British said, okay, or the Americans said, let's meet halfway. Joint Industry Conference, JIC. Let's go to 37.5 degrees. Instead of 30, you guys go out this way, and 45 will come this way. That's how you got it. That's how stupid it is.
So it really is just the middle between the SAE and the BSP. That's
Exactly.
Don't get me started on that shit.
Yeah, no, I'm not, I don't want to, Steve, and I don't want to confuse people, but really, if you take a picture, if you don't understand something, take a picture, send it to me, and I'll help you. I'll only, after a while, you'll understand it very quickly, but I'm just wanting to get your minds into it. Now, don't forget that when you start to look on the yellow, you'll start to see the dash sizes. So when you look at your bins, you'll start to see it in dash sizes, and then charts convert it into the vernier size. Does that make sense? A lot to take in an hour, isn't it?
yeah.
All right, I don't expect you to know it all. I just expect, now see there? Convex and concave.
Yeah.
So JIC is convex, BSP is concave. So you can see how that goes, and you can get that they're, and then they match on the opposite. So the female on the JIC will be concave. It'll be the opposite. I'm not going to go any further because I know it'll just confuse you. But believe me, you'll understand it when I show it to you. Okay, so I'm going to end it now because I really don't want to confuse you too much, and I can see it's a lot to take in. But I will end it with any comments, any questions.
Nothing I can think of right now.
Amen.
Well, what I'll tell you to both of you guys, you understand this, you're a lot more employable out into the market.
Right.
I hate to say that, but Steve, you know, I don't know about Steve. I personally like my people to be the best educated. And if they go somewhere else, they'll always come back because they know that we want education to work for everybody.
Right.
You understand this, you'll get into a whole new industry. In your tire industry, there's a language, right?
Yeah.
And you've had to learn that language.
Yeah.
Same thing in hydraulics and fluid conveying. But, you know, fundamentally, they're the same industry. It's a rubber industry. It's about one, and they're all about movement. So that's all you have to remember. So I'm not really going to go much further than this. Steve, is there anything else you want me to go through?
No, that's good. These guys need to go home now anyway.
Okay, but here's the thing I'd say to you, Steve.
Yep.